All right, welcome back. Today, we're going to tackle a classic IT puzzle. You've got a growing office, you've got one router, one switch, and a huge need for security. How do you take that one box and turn it into a digital fortress? Let's break down how we can solve this with just a little bit of network magic.
So picture this. Your business is booming. You've got HR, you've got accounts, and you need a guest network. Now, they all need the internet, but for security, for compliance, for just plain old peace of mind, you absolutely cannot have their network traffic mixing. The problem? They're all plugged into the very same physical switch. So the big question is, how do we build digital walls when we don't have any physical ones?
Well, the answer, and really the first hero of our story today, is a concept called VLANs. That stands for Virtual Local Area Networks. And trust me, this is where we get to perform some seriously cool network magic.
Now, the keyword you really want to latch onto here is logically divided. We are not taking a saw to our expensive switch, I promise. Instead, we're using software to tell the switch to create these separate, totally invisible networks that all run on the exact same piece of hardware. It's kind of like creating digital departments inside one big physical office. So let's really dig into why this is such a game changer. Back in the day, if you wanted to isolate 3 departments, you'd literally need 3 separate physical switches, a total mess of cables, and yeah, a much bigger budget. With VLANs, we use the gear we already have. It's the difference between building 3 separate buildings versus just putting up some really good soundproof walls inside one. It is cheaper, it's cleaner, and way more flexible. Okay, so why bother with all this? What's in it for you? First up, and this is a big one, security. If that guest network accidentally gets some malware, it's trapped. It's stuck in its own little bubble, it can't jump over and mess with the accounts department. Second, performance. It keeps all the network chatter from one department from slowing everybody else down. And finally, and maybe most importantly, your own sanity. It just makes managing everything so much easier.
All right, theory is great, but how do we actually do this? How do we tell the switch what to do? This is the part where we roll up our sleeves and start building those digital walls we've been talking about.
You know, it's really just a simple 2-step process. First, we just tell the switch, hey, I need you to create these virtual networks. We'll call them VLAN 10, VLAN 20, and so on. Then it's like we're just walking down the row of physical ports on the front of the switch, and we're telling each one which new virtual team it belongs to.
Think of this table right here as our blueprint. It's our digital office directory. We've decided VLAN 10 is for HR, and they'll get the first 16 ports. VLAN 20 is for accounts, and they get the next block of 16. And VLAN 30, that's for our guests, and they'll use ports 33 through 44. See? Simple, clean, and totally organized.
Okay, let's look at the actual commands. Now don't let this scare you. It looks like tech jargon, but it's super straightforward. The interface range part is just us saying, hey, I want to talk about ports 1 through 16 all at once. Switch port mode access just tells those ports that they're for regular devices like computers. And then that final command, switch port access VLAN 10, that's the magic right there. It's literally like putting a digital sign on those 16 doors that says HR department only.
All right, so our switch has done its job. It's put everyone into their own private rooms, but now what? They're all stuck in there. They need a way to get out to the internet, and that is a job for the router, the real brains of this whole operation. We're going to use this awesome method called router on a stick. And yeah, it sounds a little funny, but trust me, it's incredibly powerful. It just means we use one physical cable to handle all our different VLANs. And we'll do it in 3 steps. We'll create some virtual doorways, we'll set up an automatic address giver, and then we'll configure a single gateway to the internet that everyone can share.
So you might be asking, wait, how can one single physical port on the router listen to 3 different conversations at once? The answer is sub-interfaces. By just adding that little .10 to the end of the physical interface name, we create a virtual doorway that only listens for traffic that's been tagged for VLAN 10. Then we give that doorway its own IP address, and that becomes the official gateway for everybody in HR. And then we just rinse and repeat for all the other VLANs.
Okay, next up, handing out addresses. I mean, can you imagine manually configuring every single computer? What a nightmare. So we set up something called a DHP pool on the router. I want you to think of this like a super efficient receptionist. When a new HR computer plugs in, the router sees it's on VLAN 10, and it just hands it a fresh IP address from the 10.10.10 pool. It's automatic, it's fast, and it's pretty much error-free.
And now for the grand finale. The one command that ties this whole thing together. We've got all these private internal networks. How in the world do we get them all out to the public internet using just that one public IP address our internet provider gave us?
And here it is. This one line of code might look a little crazy, but it is the key to everything. It enables something called Network Address Translation, or NAT. This tells the router to take all the traffic from all our private little VLANs and cleverly disguise it so it looks like it's all coming from our one public address. And see that little word at the end, overload? That's the secret sauce. That's what lets everybody share that one single address. This is the linchpin.
Okay, deep breaths. The config is in. The commands have been typed. Now for the moment of truth, right? Let's plug some stuff in and see if this whole thing actually works.
First up, HR. We're going to plug a laptop into one of those first 16 ports we assigned to VLAN 10. What's going to happen?
And success! Look at that. The laptop automatically gets an IP address of 10.10.10.3. This is awesome because it proves two things. Our DHCP server for VLAN 10 is working, and the switch correctly put that laptop into the HR network. One down.
Okay, HR is good to go, but now for the real test, right? The test of isolation. Let's take a different laptop and plug it into a port we assigned to the accounts department. That's VLAN 20.
And boom, it works. This laptop gets a totally different address, 10.10.20.3. This is perfect. It proves that our segmentation is working. The switch knew exactly where to put this device and kept it completely separate from HR. Our digital walls are rock solid.
Okay, one last test. The big one. Can they actually get out to the internet? We open up a browser on the HR machine and the accounts machine and yes! Both of them can browse the web perfectly. Our NAT configuration worked. It's taking both of those separate, isolated networks and funneling them out through our one internet connection.
So there you have it. We took one switch, one router, and we built a secure, segmented, multi-department office network from scratch. But this opens up a really interesting next-level problem, doesn't it? Right now, the departments are completely isolated. But what if, just sometimes, someone in HR actually needs to access a file server over in the accounts department? How do you poke very specific, very secure holes in these digital walls? Well, that's where things like access control come into play. But that is a story for another explainer.